Welcome to another class. Um, in this chapter, we'll be talking about if statements. Um, the best way for me to describe if statements is think about walking down a path and you come to a fork in the road. You could go to the left or to the right. That's kind of what happens with if statements is if the if statement is true, we go to the left. If it's false, we go to the right. It allows us to be able to execute uh, a piece of code and not execute maybe another piece of code. So in this chapter, in this lesson, we'll be talking about the purpose of the selection structure. We'll describe a selection structure using the if then else statement. We'll describe comparison operators. We'll describe logical operators. We'll identify the order of precedence for operators. We'll compare strings using the two upper, two lower, and trim methods. We'll explain nested selection structures, and we'll explain how to create multi-alternative selection structures using the if then else statement. And lastly, we'll explain how to create multiple alternative selection structures using the select case statement. So selection structures. A good example is the one that we have down here in pseudocode, where we have, if it's snowing outside, we'll wear a heavy coat, wear boots, and wear gloves. And we do these three things when if it's snowing outside is true. If it's not snowing outside, we don't execute any of this, and we just start down here after the end if statement. So we only execute this code here if this is true. If the statement if the statement in the if statement is true, which in this case is it is snowing outside. Now, the dual alternative to this is you have your condition here. If the number of guests is at least 200, if that's true, we will receive the large banquet hall and hire a band. If it's false, in other words, we don't have at least 200 guests, we do this second part here, which is reserve the small banquet hall and hire a DJ. So the true path gets executed, or this body gets executed when our if statement is true, and whenever it's false, we execute the second half here. So we can also look at it this way in a flow chart. If it's snowing outside, true, we do these three. If it's not snowing outside, we skip these three and just go on. In the dual alternative, if we have at least 200 guests, if that's true, we execute this part here, which is reserve the large banquet hall and hire a band. False, we go this route and then continue on. So we need to figure out how to write this in Visual Basic, and here's the syntax in Visual Basic. We start off with the keyword if, and then some condition that evaluates to true or false, then the keyword then. Then we have a statement block, a body that is executed when the condition is true, and then optionally, that's what this square bracket here means, else, then some block of code, Visual Basic code, that we execute when the condition is false, and then we end the statement with an end if. Okay, so I believe we'll see an example here in just shortly. To be able to do some of these things, we've got to build the condition. One of the ways to do that is to use comparison operators. Visual Basic uses the equal sign to check to see if something is equal to something else. If you've used C-based languages such as C, Python, whatever, there's a double equals, but Visual Basic only uses a single equal sign. Then we have the greater than sign, greater than or equals, less than, less than or equals, and not equal. The not equal is two symbols, the less than sign and the greater than sign next to each other like this. So here's some examples. If the state is equal to Illinois, then we'll execute some statement. If the hours is greater than 40, if the max is greater than or equal to 75.65, and so on, as you see here. Now we'll talk about precedents in just a minute, but if we're talking about, I'm not really sure, to be honest, why they have this here, but they're showing you the order of precedence with mathematics, in math. So if you have a greater than or equal sign, any of these comparison operators, you evaluate what's on the left or the right, and then you compare the end result. So as you see here, 14 divided by 2, that equals 7. And then you can do the math on the other side, and you see you get 7 less than 9. And so you want to evaluate the data or the numbers, the equations on both sides first, and then the last thing you do is compare here. So I kind of see where they're coming at now. I didn't see the comparison operators whenever I first glanced at this. So the same thing over here too. We do the multiplication first. You do multiplication and division first, then you do addition and subtraction second. And as you see here, we get down here at the bottom where we've got a single number on the left, single number on the right, and then we can evaluate that. So here, let's look at an example. Now let me scroll up. Oops, it was down closer to the bottom. All right. Here is an if statement in Visual Basic where we're checking to see if the number of items purchased is greater than 5. If it is, we'll give a discount. The discount seems to be 0.1, so that's like 10%. So you would give a 10% discount if somebody ordered at least 5 items. So if purchase is greater than or equal to 5, then we execute this statement. If the number of items is less than 5, we just jump past the if statement and continue executing code. So we can see there. Okay. Moving on. Here's another example. Here's an example to where we've got an if else. If the net income is less than 0, we change the for color of the net label to red, else it's going to be black, if that makes sense. Quite often if they say you're in the red, it means that it's a deficit. In other words, you're less than 0. You've got like a negative amount. And if you're in the black, as an expression, they sometimes say, especially around Thanksgiving, they'll say, oh, is a certain company in the black or whatever. Sometimes they talk about like Walmart or something. What they mean is that company going to be profitable, or is the income greater than 0? And so if the net income is less than 0, it's red, else it's going to be black. And you can see that here in this example here. So we have 15,000 for the income. The expenses are 9,500. So we have got a net income of $5,500. Over here, we've got an income of $15,000, but we've got expenses of $15,700. You see here, we've got a net loss of $750. Okay, logical operators. Sometimes we want to have several conditions appended together so that we can make more complicated conditions. And we have like the not, and, and also, or else, and XOR operators. So here in example 1, we're going to use the not. If somebody's not a senior, then we perform some kind of a task. So that's using the not operator. In the second example, we're looking at the rate is greater than 0, and also the rate is less than 0.15%. So we want it between 0 and 0.15. Then we execute some code. Third example, we're looking at a code to see if it is equal to a 1, and also the sales is greater than $4,999. And so we check to see if this condition is true and this condition is true. If they're both true, then we would execute the code. In the fourth example, we've got an or else. So we're checking to see if the code is equal to 1 or the sales is greater than 4,999. So only one of these two has to be true. And in the fifth example, we're looking to see if a coupon is equal to use, X, or the string coupon is equal to use. Excuse me. We're looking to see if the string coupon is equal to use or the string coupon 2 is equal to use. So in the XOR, only one of these two should be true for it to return true. The XOR is the one that I probably use the least out of all of these. And you'll probably find that as well. So here's a truth table for the logical operators. If the value of the condition is true, the not would just flip it from true to false. And if the condition is false, the not would just flip it to the other, which is true. The and or operator will, if the first condition is true, it'll check to see if what the second condition is, and that actually is what the result will be. So the and also, when the first condition is true, the result will be what the second condition is. And then whenever and also is false, you always return a value of false. The or else, when condition 1 is true, we always return true, because it doesn't matter what the second condition is. You only, in the or statement, only one. And then with the false, whatever the second condition is what the result will be. So when you got false or true, you end up with true, false, or false. It's going to equal false. And then here we have the and operator. It has the 4 conditions here. The and operator, the easiest way to remember it is that both conditions have to be true for the result to be true. For the or operator, the only time that the result of the or operator is false is whenever both operators are false, as you can see here. And the XOR, always the conditions need to be different for it to be true. So for example, if you got true XOR true, that's going to be false. True XOR false is going to be true. False XOR true is true, and false XOR false is false. So with the XOR, if both conditions are the same, you're going to end up with false. Otherwise, it's true. Let's look at a few logical operator examples. So in this example, whenever somebody clicks a button, it'll check to see if the hours variable is greater than 0. And it'll also check to see if the double hours is less than or equal to 40. If it is, then it will calculate the gross and set the gross equal to whatever the hours times the rate is. Otherwise, it will just say that there is no gross hours or gross pay, I'm sorry, gross pay, or just set it to NA. You could also, instead of doing it the first way with an and, also you could do it with an or statement by looking to see if the hours is less than 0 or the hours is greater than 40. If it is, then that doesn't make sense. There's something wrong with the hours, because in this example, we're going to assume that somebody only works between 0 and 40 hours. There's no overtime pay. I believe further up in the document, it actually explains that the number of hours worked must be greater than 0, but not less than 40. Right there. If the hours work's not valid. So by following that, this logic, then we would output NA if the hours is less than 40 or the hours greater than 40. Else we would calculate the gross pay and then output that. And you can see that down here in the output here. Summary of operators. Okay, we've talked about several operators. We've got several mathematics, this really shouldn't be too much of a surprise here. We first got the exponent, which we really haven't talked about, but it's just the caret symbol, which is that little arrow thing that points up. And that has the first precedence. It means that gets executed first. Then we've got the negative sign and, or not negative. Yeah, we got the negative sign, which is the opposite of the sign of what the variable is. It says reverses the sign of the number. Then we got multiplication and division that's done next. Then we have integer division, which what that does is it returns an integer value. Mod is really just the remainder of a division. So remember in school, whenever you would do a division, let's say 5 divided by 7, or 7 divided by 5, it's 7 divided by 5. You get 1 remainder 2. Well, 2 would be what's returned by mod. It's just the remainder of the division. Then you've got the addition and subtraction symbols. Your comparison operators, where you're checking to see if something's equal, greater than equal, less than or equals, or not equal. And then you got your logical operators, not. Remember that returns the truth value of the condition, or reverses the truth value of the condition. True becomes false and false becomes true. And also an and, all subconditions must be true for the compound condition to evaluate to true, or else only one of the subcondition needs to be true for the compound condition to be true, and XOR one and only one of the subconditions can be true for the compound condition to be true. So this is a really good table right here. This kind of summarizes what we've talked about with all the different operators. So that's definitely something maybe to note, and that'd be something good to look up if you're taking some type of an exam or studying for an exam. String operators. Oops, let me go back up. String operators. Or string comparisons, sorry. String comparisons, quite often we want to check to see if two sets of text are equal or the same. Uppercase K is equal to lowercase k, that will evaluate to false, although they're not the same. And so to do that, to check to see if these two are the same, we've got to do some little magic to make it work. If you want these two to be the same or to be seen as equivalent, you can use the two upper method or the two lower method to make them both the same. So here's some examples. Let's say in a state string, it's equal to ky. What we'll do then is uppercase that string, and we'll check to see if it equals ky. So even if this is lowercase, if a string state is equal to lowercase ky, by having this say two upper here, it's going to take that and convert it up to uppercase ky. Now, if ky is already uppercase in state, then two upper really doesn't do anything. It just leaves it alone. Same thing here in example 2 is we'll check to see if the name variable two lower is equal to string name two lower. So these could be, it'll convert whatever's in name 1 and name 2 to lowercase, then it will do a comparison between the two. Here, what happens in example 3 is whatever's in state, we uppercase it and then put it into the state label. And example 4, we take name, uppercase it, put it in string name, and string state, we lowercase it and put it in string state. So this is perfectly valid, this last statement here. Okay, there's a trim method for string that will remove ending white space like LA space. By putting the trim on it, it would remove the last space so that then you could do a valid comparison on it. And note here that you could have the trim method before or after the two upper and two lower methods. Doesn't matter which order, it'll work fine either way. So let's look at a few examples here. So we have, here's an example to where the shipping will be equal to 0 if the code variable, we trim it and then set it uppercase whatever in code and check to see if that equals free ship. If it does, we set it equal to 0, the shipping cost. Else we set shipping equal to 5, which is probably a certain percentage of the cost for the items. You could also do the exact same thing by writing it like this. You could say the code is equal to text code trim upper, and then just check this variable string code to see if it's equal to free ship. That's also valid. Or you could do it this way to where instead of doing the two upper, you could do two lower and then have what it's compared to be all lowercase. So all three of these do exactly the same thing. The only difference is this bottom one just changes it to all lowercase while the two above it convert the text to uppercase. And we see that here. Here's an example where it's actually used in some code. And here's the output here, where this code is equal to free ship. It will take that code, it'll trim it, make sure there's nothing on the end, and then it will uppercase free ship and check to see if it's equal to free ship here, and it displays the shipping cost here. Now we can make these much more complex. For example, you can have if statements within if statements. Notice here on item number 3, we have an if statement. If the value in the int age variable is at least 18, we check then to see if the person's registered. If it contains a Y, it means you can vote, else you cannot register before you must register before you vote. Else, and this else statement, this last else statement goes with the first if, displays you're too young to vote. So let's look at the flow chart for that. Here you start off, you declare these variables, and then you check to see if the age is greater than or equal to 18. Let's go with the easier one, which is no, you're not. It comes over here to display you're too young to vote, and then we stop. If we are at least 18, it comes here and it does another check. It checks to see if we're registered. If we are registered, if registered is equal to Y, we display you can vote, else it's going to be false and it'll display you must register before you can vote. So here's the pseudocode. You could actually do it a different way. If you want to check first to see if the value in age is less than 18, then you would automatically display you're too young to vote if that statement is true, if the int age is less than 18, else then you got another if statement here to check to see if the person's registered to vote or not. So the two statements are equivalent. They'll produce the same output. It's just the way that they're created is slightly different, depending on how you want to look at it. And so here's the flow chart. Notice that before, whenever we were doing the check here in this square, whatever you want to call it, whenever it was true, all of the logic was over here. Now all the logic is on the false side. But both of those are pretty much equivalent. So you can see that here, if int age is greater than or equal to 18 versus if int age is less than 18. So study this a little bit and check to see, check to see that you understand that. Really all they've done is just change the bodies in the if statement and in the else statement and just swapped them around is really what they did. And then also they changed the condition is all they've done, is they're just the opposite of each other. Okay. Multiple alternative selection structures. There's times to where we'll be able to have if-else statements within if-else statements. The example we saw before was an if-else statement within an if statement. But in this example, we have if-else within an if-else. And so it can get a little bit more complicated. So here we got a flow chart that we have a warehouse, whichever warehouse it's in. If it's in warehouse A is in Tennessee, warehouse B is in Kentucky, C and D is in Louisiana, and then other means that it doesn't make sense. So it's got to be A, B, C, or D. So we can write that by writing some code like this. You could actually write an if statement and then write it like this: if string warehouse is equal to A, set it equal to Tennessee, else if string warehouse is equal to B, then Kentucky, and so on. Notice this structure. But you can write pretty much the exact same thing in version 2 here, where you have an if, and then if, else if, else if, else if. So if warehouse is equal to A, location's Tennessee, else if the warehouse is equal to B, location is Kentucky. Notice that version 2 is much cleaner than version 1. So keep that in mind. You've got several different conditions like that. You may want to write it so it looks a lot like version 2. Even though both of these are equivalent, they produce the same output. Version 2 is superior to version 1 because it is cleaner and easier to read. So if I saw version 1, and if you wrote something like version 1, I really should make a comment, take off some points saying, no, you could write this, make it a lot cleaner by writing version 2. We can also, if you can write something as an if, else, if statement, quite often you can use something called a select statement. A select statement allows us to be able to simplify the way that it looks even further. Notice down here, instead of putting the like warehouse is equal to A, we put warehouse right here in the selector expression, and then say case, and then our value A, and then we can set location equal Tennessee, and then say case B. And it's implied that we're comparing A and B, C and D to this variable string warehouse. So see how much cleaner this is and easier to read than even the version 2 that we saw before. In the select, let me see where we're at. Let me scroll up here. We can specify a range of values in a select statement. For example, there's times to where like quantity ordered 1 to 5, the price per item is going to be 25. 6 to 10, that's 23. More than 10 is 20. Fewer than 1, it doesn't make sense. You can't buy 0 items. So your select statement will look something similar to this. Select case int quantity, which quantities are variable, case 1 to 5, price is 25, case 6 to 10, price is equal to 23, case is greater than 10, we say price is equal to 20. And to say that if we don't know what the upper limit is, like right here it says more than 10, we would just say is greater than 10, and it knows that any value greater than 10, this statement here would be true, and so then price is equal to 20. And to make this a little bit more valid, since we know that our quantity possibly could be equal to 0, we really should add this case else and say int price is equal to 0 here. So that way, just in case something happens to where somebody doesn't select anything or select a quantity, or like a negative value or something like that by accident, we know that the price is 0. It just doesn't make sense. Okay, so that's pretty much it for this lesson. I'm really glad that you guys attended this lesson, that you listened to it. Really appreciate it. And I will see you next time.